In these questions, we're going to be using data to work out the relative diameter of the moon. The data has been collected in total lunar eclipses and is given in the table. So to work out the diameter of the moon, we need to work out the ratio between the U1 to U2 time and the U1 to U3. So firstly, we're going to work out the time difference between U1 to U2. So U1 to U2 is 2141 to 2252. So we can see that that difference is 1 hour and 11 minutes. And we're going to convert this into minutes. So that's 71 minutes. We then need to find out the time between U1 to U3. So U1 was at 2141 and U3 was at 2 hours 19. So that's 4 hours and 38 difference, which is equivalent to 278 minutes. 4 multiplied by 60 is 240, plus the 38 gives me 278 minutes. We then know that the ratio between those can be used to work it out. So we know that the diameter of the Earth in time is 278 minutes, whereas the moon was 71. And we can use the equation, the information that's given us, which tells us that the diameter of the Earth is 14,000 to work out our moon value. So what do we need to do to get from 278 to 14,000? We need to multiply by roughly 50.76. So we need to do the same to this side, and rounding gives me an answer approximately 3,575 kilometers. We're going to use the same method for the second table. Again, we've got the same thing. So we need to work out the time taken between U1 to U2. So U1 was at 7:14, U2 was at 20:47. So that time difference is 1 hour 33 minutes, which converted into minutes only is 93 minutes. U1 to U3, so again we're starting at 14 minutes past 7, going to 23:52, is 4 hours and 38 minutes, which becomes 278 minutes. Again, we can think about the ratios that we've got. So the moon was 93, and the Earth was 278. Again, we're going to use the data in the table, which is 14,000 kilometers of the diameter of the Earth. So what do we need to do to go from 278 to 14,000? Well, we times by 50.76. So I'll do the same to this side. 50.76 multiplied by 93 gives us around about 4,683 kilometers. A little bit trickier in this question because we've got to work out a missing value for U2. So we're going to work almost backwards on this. So we know that the moon has a diameter of 3,479 kilometers, and we know that the Earth has a diameter of 12,742. We can then work out our missing values. So U1 to U2, and we're going to do U1 to U3. So U1 to U3 is simple because we've still got the times there. So the difference between U1 and U3 is 5 hours and 37 minutes, which is equivalent to 337 minutes. This is equivalent to the diameter of the Earth. And so therefore, what do we need to do to go from 12,742 to 337? Well, we need to divide by 37.8. So we'll do the same to this side. If we do that, we get 92.01. What this means is that the difference between U1 and U2 is approximately 92 minutes. So we know that the time from U1 to U2 is 92 minutes. So if this was 7:14, we need to add on 92 minutes. So firstly, we can add on an hour, which gives us 20, and then we need to round on the remaining 32 minutes, so that will be 46. So the time of contact at U2 will be 20:46.